No, because if I start dry, no nothing inside, I spin it. It doesn't do anything, right? The pump doesn't pump air, okay? It pumps liquid.
Maximum suction head a pump can have. Careful pump selection is required to avoid problem of cavitation. Current pump can have. Careful pump selection is required.
Careful pump selection is required to avoid cavitation, and we have this NPSHA and NPSHR. Who want to help me with that? Net positive suction head. What about A? Available. Okay. NPSHA is net positive suction head available. NPSHI is net positive suction head required. We will talk about it more in the actual lecture.
To avoid problem of cavitation. Current impeller type is enclosed. Semi-open and open impellers are also in use depending upon application. If the working fluid is cloggy in nature, it is preferred to use open kind of impeller, but they are slightly less efficient. Mechanical design of centrifugal pump is always challenging. A shaft is used to connect between the impeller and motor. Since water pressure inside casing is huge, a proper sealing arrangement is imperative in arresting water leakage through shaft casing clearance. Mechanical seal or stuffing box-based mechanism is used for this purpose. Impeller is mounted on bearings, but at suction side of impeller, it is not advisable to fit a bearing since it will block the flow. So bearings have to be fitted at the other end. This means impeller is mounted like a cantilever. For high flow rate pumps, a bearing housing with cooling oil is necessary for improving life of bearings. We thank Kurlaskar Brothers for their technical support and creation of this video.
Okay, sometimes there's a cooling oil for those bearings. Okay, this type of pump, is it centrifugal or positive displacement? Centrifugal. Okay, very good. Because it says so over there, right? Next one, rotary lobe. Okay, this is rotary lobe. Is this centrifugal type? Positive displacement. So it's mechanically move the volume forward. So when it comes in, it goes to the side.
Alpha valves called rotary lobe pump. In addition to being alpha valves called rotary temperatures and pressures, in addition to being temperatures and pressures, our rotary lobe is the most extensive SIL heavy duty shaft containing a
Okay, this is another rotary lobe. Let's take a look at the inside. Okay, we have flow.
Is the best solution for pumping liquids containing solids with minimal damage. For improved volumetric efficiency when transferring low viscosity liquids, the bi-lobe rotors are also available in non-rolling alloy. This allows closer pump head clearance and reduced slip.
So this thing can do solid particle, right? But it could get stuck. Every time that we have mechanical seal, anytime there is mechanical seal, we have solid particle, it will create a tear and then think about this, if I have a small sand particle and that small sand particle get into this part, it scratch the surface, right? It create tear over time, it won't be good. But this can actually do a little bit of the solid particle.
Are these hybrids or big hybrids?
I think if we buy a bigger one, it will be a hybrid. So this, most of the time, positive displacement type is not for high flow rate. Okay, most of the time. PD type is for high pressure. Centrifugal type is for high flow rate, low pressure application. It's similar to the chart that you see in the compressor case. You remember the compressor have the selection and where's this chart? So the selection for the compressor, you see this chart. We have a multi-stage, centrifugal type, and positive displacement type. So it is kind of similar. Instead of liquid, compressor to gas, does that. So now we know rotary lobe and centrifugal pump. Let's take a look at another one, progressive cavity. I think it's kind of fun, right? So, progressive cavity pump can handle solid, okay? It pushes the liquid volume forward mechanically. It pushes the liquid volume forward mechanically by spinning that screw. Sometimes they call screw, but okay, we have another type of screw. So just stick with the progressive cavity pump. So this motion push the liquid forward mechanically. So that is so this is PD type. Okay, this is PD type. Multi-phase pump. Multi-phase pump.
For over a century and a half, Flowserve has pioneered virtually every significant advanced development efforts. It's the MP1, a double suction, twin screw positive displacement pump, specifically engineered to handle the most aggressive challenges in multi-phase oil production. The MP1 readily accommodates rapid changes in oil viscosities, water cuts, and gas volume fractions, all of which vary over the life of an oil field. Its positive displacement design inherently offers several operating advantages over other pumps, including greater pressure boosts on high gas volume fractions, improved efficiency when pumping high viscosity products, elimination of gas vapor lock, constant torque loads on the pump drive system, and lower vibration and noise levels. The Flowserve MP1 is built with a one-piece integral rotor, offering greater shaft strength and high torque handling capability when compared with multi-piece rotor designs. Robust regular bearings at each end of the shaft support full hydraulic loading, even at 100% gas operation when the hull.
So this thing is, they call screw. The previous one is not screw, it's progressive gravity. So we have this type for the compressor to screw compressor, and this is similar thing for screw pump. This unit do multi-phase pump. It can pump, it claims to be able to pump both gas and liquid. It will be efficient if we just pump just liquid. Okay? That's a multi-phase pump. And next one. Okay, multi-stage pump. Let's take a look at multi-stage pump. how many stages is that? I think the sound didn't do anything. Alright. We have that number of blades. You see the number of impeller inside? So when it go from one impeller, it go to another one, into another one, they put it in series. So when we put pump in series, is that going to increase the flow rate or pressure? Pressure. Does it increase the flow rate? No. No. Put centrifugal pump in series, it increases what? Pressure, not flow rate. Okay? So they put this pump together in series. And the rate flow, okay, it come in, go to the first stage, second stage, and third stage inside this. Okay. You see the flow direction? So when we have multiple of them in series, this increases the pressure a lot. Alright, the next one is about gear pump. Okay, gear pump is another type of PD pump. It has a gear. It looks similar to that flow pump. Okay, you have flow coming in. Okay, flow go within this gear and coming out. So it go around the pump like that and coming out on that side. If it spin faster, it flows faster. Okay. What is the limit of this spinning? Can we just spin as fast as we want to? So, ask some question. Kate M. Gentry. Kate, if I spin too fast, what happened?
Feel like a break.
Do I have bubble?
Bubble?
Yeah, if I spin too fast.
Oh,
So if I spin too fast, this means I increase the pressure very quick. I try to deliver faster than it comes to that point. I may like break it apart and create a bubble. So if I spin too fast, the pressure may go below the vapor pressure and make bubble coming out. Okay. So that is a gear pump. Gear pump is a positive displacement type. Another video for the gear pump. Okay, inside there's a gear. So let's see how it works. So it flow around the gear, okay, like previous one. It go to the side. So gear pump, is that the positive displacement type? Yes. Okay. Vent pump. You remember the vent compressor? Did you have vent compressor? Okay. What type of compressor that is good for vacuum? You still remember? Good for vacuum, or at least I say read it for yourself. Find out, okay, and maybe you answer it next time. Yes. Why gear pump is PD pump? Gear pump, okay, centrifugal pump work by have convert kinetic energy to pressure. Okay, the way that centrifugal pump work, you see when it's coming in the middle, and it go out to the side, right? So when it go out to the side, It comes in the middle, it flow out radially. So when it flow out radially, the cross-section area of the flow go up, right? Close to the eye is less. Away from the eye is like more. So when it flow, have more cross-section area, the velocity go down. And when the velocity go down from the very long, pressure go up. Okay? That's how it works in short. Okay? We will talk more about it, of course. Gear pump. Gear pump is physically, mechanically move the volume of fluid forward. It doesn't use a spinning motion convert the kinetic energy to pressure. It's not that. It moves the fluid volume around the gear to the discharge side. When it's mechanically move the fluid volume, that is positive displacement type of arm. Okay. So vane pump, we have vane. Is there anything? So you see the sliding vane, the black part. We have inlet from the left and discharge. Okay, it's about to spin. No. So you see this vein, it's coming out. Sometimes it goes back in, sometimes it's coming out. Okay.
Sometimes it go in.
The fluid move around the vein like this. Okay, move from here to this side. So it's like mechanically push the volume forward. So this time, even though it's spinning, it's not the centrifugal type, it's a positive displacement type. Okay? There's a vane pump, diaphragm pump. Diaphragm pump may be good for solid pipe, and you see.
EX 1500 76 millimeter 3-inch advanced aluminum pump. The liquid chambers are alternately filled and emptied by fluid that is drawn through a common inlet and discharged through a single outlet. The diaphragms in each chamber are linked by a single shaft, allowing them to move in unison. The air valve directs pressurized air to the back of diaphragm A. This begins chamber B's suction stroke, which starts as diaphragm B is moved toward the center of the pump, thereby creating a vacuum in chamber B. Atmospheric pressure then forces fluid into chamber B past the inlet ball valve. When the pressurized diaphragm A reaches the limit of its discharge stroke, the air valve redirects pressurized air to the back of diaphragm B. This begins the discharge stroke of chamber B. The hydraulic forces developed inside of chamber B force the inlet ball onto its seat and the discharge ball off its seat. This condition allows fluid to flow through the pump discharge. The same
Is it clear enough? We have the ball that can move up, down a little bit, and the middle part redirect the air pressure. So if air pressure goes to one side, the diaphragm move one way. When it move another way, it like keep pumping, and then the fluid go up. Okay, it's physically suck it up because the movement of the diaphragm. Okay, so this is positive displacement type.
process occurs in the opposite chamber, constituting one full cycle. The pump will continue to run until inlet air supply is interrupted or discharge pressure rises to equal that of the.
So when the diaphragm moves, it kind of sucking everything up. Good. That is diaphragm pump, and that's a positive displacement type. And we have another one. Okay, this is tell the pressure inside. Dark green is higher pressure. Okay, and fluid, the way it moves, when the diaphragm moves, so the diaphragm itself push it out and suck it in, because we have the ball to move up down. Okay, so That's how it works in short. Basically, it's another type of positive displacement type. Positive displacement pump. ESP. What is ESP? Electrical submersible pump? What kind of pump is that? Several centrifugal pumps together, right? I don't think the sound is relevant. Okay, here comes the latest speed. We separate some gas out first. And look at that. How many stages? Many, right? So from what I see over there, it's just 1, 2, 3, 4 at least. It's a multi-stage centrifugal pump put in series. Okay? Multi-stage centrifugal pump put in series is become electrical submersible pump, ESP. Okay? So ESP, is it PD type or centrifugal type? Centrifugal, okay? In general, it's centrifugal type. Self-priming, okay, many of you may already know priming. Grant Goodman. Grant Goodman. What is self-priming? What is priming for a pump? It's filled. It prime itself. So self-priming, for the pump that can do self-priming, can be start dry with nothing in the pump. Yes? Who said yes? So self-priming, we can start dry with nothing in the pump. Who? What? Oh, okay, self-priming. Let's take a look at it, okay, how it works. I don't think we can start it dry. We need something inside before we can do anything with it for self-priming.
This video is a future video to inform and instruct into the operation and troubleshooting of self-priming centrifugal pumps. Before we get started, let's review the piece of equipment we'll use for our priming demo. It is the glass-based pump. The glass-based pump consists of our very own 11.5 A3 E1/2 single-phase unit, driven by a variable frequency drive. It is the exact same 11.5 A3 that we build on a regular basis here at Gorman Rob, with one small exception. We have taken this particular pump, the 11.5 A3, and we have sectioned the volute casing at the same location.
Okay, let's watch when they start the pump.
That we normally place inside the pump for priming. For those of us that are familiar with self-priming centrifugal pumps, we know that we must first fill the volute with water.
We have to fill it with water first. May not be completely full, but it has to be something inside. If you start dry, it doesn't work.
We can now start the pump.
So initially there's some liquid inside, right?
Inside of the pump during priming. After we fill the volute casing with water and we energize the pump, the impeller turns in a counterclockwise rotation. The initial prime of the pump is slung through the volute stroke on the ever-increasing water channel into a pressure.
You see this channel? water can come back down. That's the key, okay? Self-priming is like a small separator. It allows liquid that come out to fall back down over there. So it creates a seal, like a vacuum. If I start a self-priming pump, we just add inside. No water, no liquid inside. It spins, it doesn't do anything, okay? It needs some liquid inside first.
Cavity or a discharge chamber inside the balloon. Inside this discharge chamber, the air and water separate. The heavy water falls back down through a recirculation port, and the air then is evacuated through an open-ended line or through an air release device. All the while that we recirculate the water inside the casing and remove the air from the top, we create a low pressure at the eye of this impeller. Due to differential in pressure, atmospheric pressure that we live around every day is higher than the lower pressure created at the eye of this impeller. Due to that differential in pressure, atmospheric pressure outside begins to force liquid up the suction pipe. As liquid moves up the suction pipe, it pushes all the air ahead of it into the balloon casing where it is handled through the recirculation process. Again, the air is handled off the top and the heavy water recirculates back down into the balloon scroll area. I'll close this valve right now and create a suction line capable of pulling a vacuum. Ahead of it moves the air, pushes it into, handles it through the
See the water coming
recirculation
out?
process, and once the water arrives, the pump then goes to complete operation.
Okay.
For more information,
Self-priming for the pump needs some initial volume of liquid. It cannot start dry. Okay? Alright, another self-priming video. Triplex pump. Okay, this one is new. Triplex pump, handle corrosive abrasive, drilling well service. What is triplex pump? You see that 3-cylinder? When I do one turn, how many times will it kind of pump? 3 times, right? Is it 3 times? So you have 3-cylinder. So this is what kind of pump? PD or centrifugal? PD. Alright, that's a triplex pump. That's how it works inside. What can I do with the exam? What do you think the exam will look like? I give you the picture and ask you, what is this? Just that. Is that easy? It's always easy when you come to class. And we have everyone come today, right? Oh, Elizabeth. Elizabeth. She's sick, okay. So we missed one, just that? Alright. Tell her to watch the video, okay? Alright, type of pump. We have PD type. PD type is, the full name is positive displacement pump. It can be reciprocating pump, rotary pump. Even though it's spin, it doesn't mean that it's centrifugal type. Centrifugal type, we have different kind of configuration. We have between bearing, vertically suspended, overhang pump, okay? Pump calculation. When we talk about pump, they want to know how many feet of water that is the discharge pressure. They don't quite talk PSI, okay? How many feet of water that it can pump? So this means I have to be able to convert from PSI to feet of liquid or feet of water. Here's the formula, okay? I have PSI. I know specific gravity. If it is water, this is just 1, okay? Multiply by that number, then I get feet of liquid. Good? And I have you know how to derive this? Yes? It's just doing conversion. Go from, how do we go from, okay, let's take a look a little bit. PSI is power per square inch. Okay? Convert inch to, okay, Okay, density is power per cubic foot. Multiplied by 144 is to change from inch square to feet square. Put water density over there. Okay. So here come, we can convert from PSI to inch of water. It is important that you know how to do this in the exam, if any. Okay? The formula is not given, you have to write down. Okay. Type of pump, PD. Okay, which line is PD? The vertical line, okay, this is a plot between flow rate. See this flow rate and the pressure. The line that looks vertical, is that PD or centrifugal? PD. Okay, why do we expect that? Anyone want to help me? No? What's your name, sir? Next to Martin, what's your name?
Joe. Alex, this side, Alex.
Alex. Okay, let's do Joe. You want to do Joe?
Yeah.
Joe. Okay. Joe, why do you think the vertical line is a pump curve for PD? And this curve thing is for centrifugal pump. Why do you think that is, Joe? Yeah, easy, you might like it. Joe.
Because the positive displacement can handle more rate. I don't know.
So,
Are you saying like why it's shaped like that?
using this pressure, let me talk about centrifugal pump. If I have high viscosity, okay, high viscosity, the pump curve shifts this way. When it shifts down, this means if I have a pressure, okay, head pressure, it cannot like pump at the same flow rate. Okay, so let's say we look at one pressure. How about this line? Okay, so when the restriction in the line is that much, okay, let's say that is maybe 20 psi. So that 20 psi means I have the pump. After the pump, it has the restriction, right? When it flow in the pump, Joe, come on. When it flow inside, we have a pressure drop. In that, this is the line that creates a restriction. And let's say that is 20 psi pressure drop. If the fluid has high viscosity, you see that high viscosity, flow rate is less. If it has low viscosity, flow rate is higher, even though it has the same 20 psi, okay, or same discharge pressure of 20 psi. So even though we have the discharge pressure at 20 psi, low viscosity, it pumps faster, more flow rate for centrifugal type. Okay, high viscosity, it pumps less flow rate, even though we are at the same discharge pressure. That is centrifugal type. PD type is not quite sensitive to the viscosity. Okay, Joe, do you want to like to help you?
What's up?
Why do we have this phenomena? Why PD pump is not quite sensitive for viscosity?
Just better.
Who do you want to help you?
Alex.
Oh, okay, Alex. Why is that? So PD, why it doesn't quite sensitive to viscosity? Centrifugal type, okay, let me give you a hint. For centrifugal type, it's really sensitive to viscosity. When it got more viscous, it flows slower because when it spins, okay, it spins at the same thing, but when we have more viscous, it cannot spin that fast, right? But PD, what about PD? Can we pump PD pump against a dead end? Yes or no? I have a pump, okay? I have a valve over here. Okay, I have a valve over there. I close the valve for the PD pump, then what happened?
I think mechanical energy is transferred from the PD pump to the fluid.
Okay. For PD pump, we physically move it forward, right? When we physically move it forward, we don't quite like sensitive to any viscosity. Regardless from any viscosity, one volume come in, it will always go out, right? One volume come in, it will always go out. One volume come in, it go out. But for centrifugal pump, we spin it. So when the viscosity go up, we cannot spin it that fast, so it go out at lower flow rate. But PD type, we move the volume physically forward. Okay. One of the obvious thing here is this: if we have centrifugal pump, we pump it against a dead end. We close the valve. What happened to centrifugal pump? Is it gonna break the pipe? It stop? Really? There's nothing happen. It's fine if you don't do it like 1 hour. Do it like 5 minutes. It's fine. Provided that we didn't run dry. So in the centrifugal pump, if there's a liquid inside, we start the pump against the dead end, nothing happens. And it is actually preferred to start the pump that way. Close the valve on the discharge first, then start the pump. Then open the valve. But for PD type, if anyone ever do any of that, close the outlet and start the pump. Something will break. Okay? So, you get some idea? For PD pump, if it hit against a dead end, the pipe or fittings will break or burst. Okay? Because it's physically move things forward. But for centrifugal type, it just spins. If you close it, it keeps spinning. No problem. Okay? So it is okay for pump against the dead end for centrifugal type. Let's take a look at the efficiency. Rotary type. Rotary type is PD, right? And this is a centrifugal pump. Pump efficiency versus viscosity. So when viscosity go up, efficiency go down quickly for centrifugal type. But PD it go down not as quick. Okay? So efficiency go down a little bit, but not as much for the case of centrifugal pump. Centrifugal pump is used the kinetic energy, okay, to move volume forward. That's how it works. That it spin. When it come out, you see the cross-section area of the flow. Over here is more than that, right? So it kind of flows slower. When it flow out rapidly, it flows slower. When it flows slower, the pressure goes up. And so mechanical energy from impeller transfer from the fluid to the fluid. Pump curve for centrifugal pump. Okay, depend on the pumping speed. Let me wrap it up because it's about time. So let's review a little bit. What is the content of the exam? Exam cover not this page, but this page, this page, this page, this page, and all the video. Okay, that is the content of the exam. Exam also contains ethics part, the lab that you go, the field trip that you go. Okay, I have the facility I asked you to draw. At the place number 1, do we put a heater treater or we put something else? You should be able to do it. Okay, the field trip. Draw the diagram 20 points. Diagram according to the East Campus. How do we lay the heater treater, everything. Very easy, right? You just went there. Just like, okay, come in with the separator and we have a bypass to the test separator and then it go to pre-water knockout, then go to heater treater. Did you remember that? Watch the video. There's a video uploaded. Okay? Just think about it. Okay, I think it's about time. Good luck for the exam. Try to prepare that. See you next Tuesday. Alright, goodbye. We have class this Thursday. We have class this Thursday. Please see you this Thursday. Any questions, any concerns on how do I improve?
What's up, boys?